While we know the atom is composed of more subparticles, chemists are mostly interested in protons, electrons, and neutrons. Two of these particles are located in the nucleus. The proton is in the nucleus, and the neutron is in the nucleus. The proton has a mass of about 1 AMU and a charge of +1. The neutron has a mass of about 1 AMU and no charge. The electron is orbiting outside the nucleus. It has essentially no mass. It does have some, but it's so small compared to 1 AMU that for all practical purposes, you only need to know it as a 0 atomic mass. But it does have a -1 charge. You need to be able to use this information to tell about what's going on in the atom. And we can use the information from the periodic table to help us with that. Okay, so let's look at one atom on the table, periodic table, to see what is going on with the particles. First of all, on the periodic table, this gives you the group number. There's different systems because it's changed over the years, but it really doesn't matter which system you use. Most periodic tables have all three listed. Okay, now what else does this tell us? It tells us the atomic number up in the corner, and we sometimes label that atomic number Z. It tells us the symbol for the atom and the name of the atom. And then it also tells us atomic mass of an element. And that's in atomic mass units usually. Now these may be in different places, these numbers on a periodic table. There are different arrangements. The larger number is always going to be atomic mass. The smaller number will be atomic number. And the atomic number is always a whole number, not a fractional. That's because this atomic number is the unique identifier for an element. It tells us the identity of the element. So let's take a look at hydrogen and what we know. Because the atomic number, or Z, equals number protons. The atomic mass equals the number of protons plus the number of neutrons. And in the neutral atom, the number of protons equals the number of electrons. So we know that the atomic number for hydrogen is 1, so it has 1 proton. We know its atomic mass is 1. We know it has 1 electron, because if there's 1 proton, this is +1. You need a negative charge to create the neutrality. And because the atomic mass is 1, there are no neutrons. So hydrogen has 1 proton, 1 electron, and no neutrons. Okay, now on the periodic table, let's look at another atom. Let's look at fluorine. Okay, here's an expanded view. So from this, we see that the atomic number is 9. That means there are 9 protons. For number of neutrons, we're going to subtract from the atomic mass. So that's going to equal, we're going to round this mass to 19 minus the 9 protons, and that's going to give us 10 neutrons. Now, if I have a positive 9 charge and it's neutral, I have to add up to 0. It means that my number of electrons has to be 9. So 9 electrons to give me the minus 9 charge. Okay? So you need to be able to use the periodic table to determine the number of protons, the number of electrons, and the number of neutrons.